I hear that Prusa's giving up on 3D printers, and you're moving into injection molding.
Yeah, we just gave up and started injection molding everything.
Hey, Joseph.
Hi, Scotty. Welcome to Prusa.
Thank you so much for flying me out here to check out what you guys have. This is your print farm.
Yes.
And I think it's what everybody thinks of. You're printing parts.
We are printing the printers here.
Printing the printers. I love it. But I realize this isn't really the start of the process. Let's go all the way back to the very, very beginning. Before even making the filament, where does the plastic come from?
I'll show you.
Okay.
So this is one of our warehouses where we store the raw materials and the plastics. This one is a little bit special because here we have the recycled plastics, but in the back you can see they call it octabins, and this is where the virgin resin, virgin polymer comes in.
And what does virgin mean in this context?
It is fresh from the factory.
Okay.
It is, colorless.
So it's not recycled. It's the opposite of recycled.
Opposite of the recycled. That sounds kind of weird. New fresh material, and this one is recycled. And when basically some of the filament is manufactured out of this bag, we just chop it up, and we make the recycled filament out of it. So
this comes as like pellets?
yes, it is like tiny pellets, and these go into the extruder at Prusa Polymers.
Awesome. So I know you're a busy guy. I don't want to take up too much of your time, but I think you've lined up some of your department heads to show us around who are experts in these various areas.
Yes, you get to speak to the real professionals.
Okay, awesome. We'll let you get to it. We'll see you later in the video, but I'm going to go off and see how filament is made.
Okay.
So I'm here with Adam. You're the head of all of the filament development here?
Yes, that's right. Well, the start of the process, it's pellets.
Got
You can take a look.
Okay. So this is PLA?
Yes.
Here? So this is
our
like,
basic polymer.
okay. Try not to spill it on the floor. This doesn't look like the PLA I normally get. This is just raw PLA.
It's raw PLA.
All right, let me put this back because I'm going to spill it otherwise. Okay, so you will add some stuff to this?
We do add color, so
Yep.
basically we add pigmentation.
You're not scooping this out with a bucket. It looks like you've got a vacuum hose here.
Yes, there's vacuum hose.
Okay.
And the material goes into dryer.
Which is this here.
Yeah.
And how does that work?
Yeah, there's the material all over the place.
Yep.
Just hot air going through,
Okay.
through and drying
Yeah.
the material. Well, we need to remove humidity
Yeah.
because it causes defects during the production, like small bubbles and stuff.
Because that steam like expands
Yes,
when you
yes,
heat it up.
yes,
Okay,
yes.
got it. And then you suck it by a hose here?
We suck it over there, through the wall, into the extruder.
All right, let's go take a look at that.
Well, the pellets goes through the hose,
Okay,
into the stour and into the extruder.
okay.
They are melted and mixed and pushed through this die head.
And this is just like a screw extruder?
Yes, there's like a really large screw
Yep.
compared to the ones you have, for example, at home
Yep.
in your hobby kit. And the plastic gets melted, and we can also mix it with color.
Where does the pigment come in?
It comes from here.
Oh, okay.
It's nothing here.
There's none in that. Yeah. What's a typical temperature relative to what you would print at for a material?
Oh, it's a bit higher because you need to lower viscosity to move it easily through the screw, through the chamber.
And it's coming out thicker than I would expect. Like that doesn't
Yes.
look like 1.75 millimeters.
It's not. At this point, the material is still melted.
Yep.
You can actually squeeze it and do a couple of stuff in it.
Yep.
And then we go to cooling.
So now we're running through a water bath.
Yes.
Can we open this here?
Yeah, you can try it.
Oh, I see. So it's just got a little like tray that it sits
Yeah,
in,
and
and
it's
then water
running
all the way
through.
around. And this is
Yeah.
hot. Like
Yeah.
this is, you're pumping a lot of heat, or it's
Yeah,
trying to
that's
pull a
right,
lot of heat
that's
out.
right. And then there is a second one. At this point, the material isn't melted anymore. It's becoming solid.
It's not fat, and you're not doing as much support on it.
Yeah.
You got it on rollers.
We still need to cool it down a bit.
Okay.
So it's really room temperature.
Yep.
But at this moment, you cannot really mold it anymore. And that's how we change the diameter. Just two belts running against each other. When you slow them down, you make the filament thicker and so on. If you move this faster, the filament is running faster from the head.
Yep.
You'll have a small diameter.
Oh, so this is the thing that's pulling it through the whole
Yes.
line.
Yes.
And depending on how fast you pull it relative to how
Yeah.
fast the extruder
Yeah.
is running,
Yeah.
you're controlling diameter. So if we go all the way back there,
Yeah.
it's basically just how much you're pulling it
Yeah.
out of the thing.
You could
That's
be pulling
crazy.
manually, but
And that's enough to control the diameter. You guys have very fine tolerance on your diameter.
this is just like basic control.
Yeah.
Otherwise, basically each of the materials requires special cooling. That's how we achieve the diameter.
This is your measurement here.
Yes. It's basically a laser that's measuring the thickness of the filament, the diameter,
Yeah.
and also like the ovality. When we finish the spool and we want to start a new one, we don't want filament to lie around or whatever.
Yep.
So we have this upper set of wheels. They'll move up and they'll actually gather the material as it's being produced. And the operator has a couple of seconds to change the spool and to start winding again.
So this is like a moving buffer for
Yeah,
filament.
basically.
It's such a cool technique.
Now you can see moving.
Oh, that's so cool. So then coming out of the buffer here, now we're winding onto the spool.
Yes.
Okay.
That is the final stage. We cannot show you, unfortunately,
Okay.
because it's secret. We have a lot of stuff going on there, but we cannot show it.
Okay. We'll respect that. And then once the spools are wound,
We can go to packaging.
yeah, great. So these are your finished, wound, perfect spools. So what's he doing here? He's got like some custom jig.
It's actually laser marking, the description of the product.
Got it. And the laser is underneath?
Yeah,
Oh, that's super cool.
it's super safe as well.
Yeah,
Because
right.
it cannot hurt your eyes.
And so then vacuum sealed in a box
Put a label on the box.
and then shrink wrap that. Awesome. And then stacked on pallets to
Yes.
go out.
Yeah.
Thank you so much.
It's
This
great to
is
have you here.
Amazing.
Hello, ahoy. My name is Blanka Čibishova. I'm here in charge of process engineering. So welcome at our Prusa farm. In 2011, we started with 300 printers. Right now, around us is more than 600
God.
printers. Right now, we have 3 models here. So we have the old MK3. And as you can see, there is a small change in the extruder. There is extra cooling. We improve it in the MK4 and they are the same as all the customer has. And what you can see is also the difference in speed, because in MK4 we use the new input shaping functions
How much did that speed things up for you?
by 50%. So
That's
so in
that must
past-
be nice for your print farm
Yeah,
production.
yeah.
And I noticed you've got your 2 kilogram spools that we saw being made downstairs.
And we have also these special hangers and so on because it's faster for the changing. And we can find also a machine for the weight, because if there is like few last meters,
Yeah.
the farmers can weigh it and see if there is enough material for another round of the printing.
Got it. That's really smart. It's
Yeah.
hot in here.
Yeah.
These guys are all wearing shorts. It's so hot.
Yeah.
What you guys call farmers here, that are
Yeah.
your technicians managing. They're actually right here. They're changing out prints, and they just come by and they see printers that are finished. And
We
Scrape
use
them off.
our ERP system. They have there the overview of all the printers, currently running printers, how many printers are in charge of them when it's finished, and they have also the queue, what is the other print they should print. Also.
okay,
This is our plastic department, or plastics.
this is everything coming directly off the printer.
The last part where we do not have complete traceability because the parts are tracked in the batches. So once the farmer harvests the parts, they are automatically uploaded to the system. Starting here, we will have the complete traceability. Who did it, when did it, how many pieces, and so on.
How do the farmers know what to print? You're tracking how many parts of each type you have in inventory?
So once you order the printer at our e-shop, it's divided into different levels. For example, if you would like to buy the black or the orange, what sheet and so on, kit or the assembled one, and it's divided into each levels of the production and beginning at the farm, and according to your orders, it's planned and they can see the queue in as a reaction on the orders.
Joe, thanks for letting me grab you. I have some questions because we're starting to get into the manufacturing process of the printer itself. So I was hoping you could walk us through like just an overview of what the different parts are and kind of roughly where they're coming from, what you're making in-house, what you're doing outside.
So this is Mark IV, part of
Yeah.
our i3 series, which is going for years. This is a very old example.
Okay.
But in general, you can see a lot of printed parts. We make those in-house. When we know that they are not going to change, we switch them to injection molding.
Is this injection here?
Yes. But generally with the parts, we are trying to make as much as possible here or locally in Czech Republic or in Europe. But obviously some parts like motors, we just cannot get in the quantities in Europe. These come from China. But the PCBs we are assembling here in-house.
The screen is coming from somebody else, but you've got a 3D printed enclosure. This looks like UV?
It's UV or screen printing, depending on how far in the production and optimization it is. For example, the frame is very nice.
Yeah, how are you making this? Is CNC?
No, this is die-cast aluminum.
Oh.
The power supply is from Delta, and also we are trying to keep the continuity. So here you can see Mark III, but there was Mark II, Mark I, and you can always upgrade in the i3 line to the new one.
So you can get a kit to go from this to this.
Yes.
I think that gives everybody, including me, a bit more context of how this comes together.
Okay.
Okay, we'll see you in a bit.
So next we process the parts. So there is a visual control if everything is okay, the first layer and so on.
Yep.
Then if there are some extra small parts or some holes are full of filament and so on, it's cut it away.
Okay. And then he's got some, is this a custom tool here? That's cool.
Yeah, this is for clearing the holes.
Ah, okay. Yeah, and then
And
you've
if
just got a
there-
regular X-Acto knife. Yeah.
And if there are stringing, he can use the heat.
Oh, the heat gun to just melt them down.
Yeah.
Oh, interesting. I see what he's trimming. Okay, so just little ridging errors or things like that get trimmed out.
So this is the last process of the plastic parts. So it's the packaging. If you order the kit, you will have for each chapter of your assembly manual bag for
Got it.
assembling.
So this would go like this into a kit for a customer.
Yeah,
I got it. Okay.
Last part of the plastics department, it's quite new. First year we have this UV printer because we started to print some labels and some instructions for the customers on the parts.
And so this is a 3D printed part?
Yeah. It's from the farm,
it. Okay.
but we need to somehow show the customers where to put filaments into multi-material, so use it to print the final instructions or the models on the print.
This is gorgeous. This just comes out super clean. If you want to learn more about how UV printers work, I did an entire video about UV printers, so that you can go check that up here, I think. Maybe up here.
Another interesting fact, it helps us to reduce the complexity because we can print the same parts, but only a different print on it. For example,
got it.
the LCD cover is the same for MK4 and for XL, only the print differs.
Oh, nice.
Here we have several sub-assemblies or small workstations where many components are tested or sub-assembled to be ready for the kits and for the complete printers.
So these were things in the kit that you would get already put together.
Yeah,
Got
but
it.
for example, this one is for complete printer because in past we have the dedicated workstations and right now everything is movable or the gigs, toolings and so on. According to the demand and planning in the production, you can change the workstation what is currently necessary to
So
be
this is the work you're
manufactured.
doing to
Yeah.
speed things up.
Yeah.
Got it. And then what's happening back here?
It's in fact similar, but it can contain only the tests.
And he's just testing cable assemblies, it looks like.
He's tested in the development database and then he's putting the QR code. We are at the pre-assembly of the final printers. So several, like around 5 main sub-assemblies are produced here and going to the final assembly of the printer. For example, the frame,
Yep.
then the X-carriage.
Yeah,
then-
this is for underneath the bed?
Yeah, for the heat bed.
Okay. All right. This looks like a finished printer station.
Yeah, that's the final assembly. So
Okay.
at the beginning of every shift, the final assemble guy, he pick all the material. He needs to build 8 printers
Okay.
per shift. So he pick up the material for 8 printers, and he started to build. This is the last station of the MK4 and MK3 production, the final check. Mainly 3 things are happening here. It's the visual control, whether are there any scratches, missing screws, missing parts, whether everything is tightened well, and so on.
Yep.
Later on, there is self-calibration, the testing,
Yep.
and the self-test. It's done by the printer itself. And the last thing is the first print.
Okay.
After that, the printer is moved back to the factory reset and sent to the shipping.
Got it. And you guys actually leave the test print from the factory on the bed.
Yeah.
So the customer receives it with the test print,
Yeah, we
showing
have
it works.
the great feedback on the list.
Yeah, it's amazing. I received one and I was like, whoa, this is super cool.
Yeah.
And then they go on this giant trolley over here
Yeah.
to go down to shipping.
Yeah, there are 24 pieces and send it to the shipping.
All right.
Right now we are standing at Excel production. Here is the production line and also the shipping part because of the size and the weight of the printer. We have here several workstations, mainly focusing on the extruder assembly. So this is the final assembly, then it's moved to the tester and packed for the customers. As you can see, it's again built in-house.
Yes,
so
of
there
course. So explain this a little bit to me, because you've got some stuff up here, but this is part of the tester, not part
Yeah,
of the...
because we are loading the filament, whether it's okay to pull and press to the tester and so on.
And so is this fully automated? He loads this in here and hits go? And
The operator only needs to put the final part there and start the test, and there he will see whether the test is okay or not.
Is it extruding filament somewhere into this?
I think there are only small centimeters because I think that the spool is like for mounts.
Ah,
So
okay.
We asked
Just
it for the
tiny
first
amounts.
time how many spools we need.
Yeah, okay.
Yeah.
Awesome. All right, what's the next step here?
These are other sub-assemblies which will be ready for the semi-assembled printer, but also for the fully assembled. And slowly we are going to final assembly and final check. It's again similar to MK4 and MK3, but bigger.
Yeah.
And also because you are not allowed to carry on your own the printer, there needs to be in the minimum 2 people carrying the printer.
Because it's so heavy.
Yeah. And because of the safety, so that's why there are also these trolleys
Got it. Okay.
according the orders.
Yeah.
And this is the last part of the packaging.
Yeah. Is this for semi-assembled? Or for
Yeah.
both?
So mainly 2 big boxes
Yeah.
where you have the Core XY, the PDU, and so on.
Got it.
Then you have a box with some accessories and also with big Haribos. We have
I
the
see,
XL, we can see they are even bigger. Not only the packaging, but the bears
The
are
bears
bigger.
themselves. So Prusa's big on recycling, and here they've got their grinder where they grind down not only filament that wasn't produced properly to make new recycled filament, but also they grind down the reels themselves to be injection molded into new reels. So he's pulling apart the reels to get the filament off and separate it because this is PLA and this is polycarbonate, so they need to be ground separately. It grinds it down to these fine pellets here, and that either goes back into an extrusion line or back into the injection molder. I hear that Prusa's giving up on 3D printers and you're moving into injection molding.
Yeah, we just gave up and started injection molding everything.
Yeah, okay. So you're going to stop making 3D printers and
Yeah,
start making
yeah.
home injection molding machines.
Yeah, that's right. Yeah.
Okay.
Well, we started injection molding the spool sides we use
Yep.
for Prusamen because we just produce that many that doesn't make sense to 3D print those,
Yeah.
and it's easier to inject them.
Yeah.
And we also started injecting a couple of parts for 3D printers.
Got it. And this is things that aren't changing a lot, so
Yeah.
the cost of making a tool is not, you're not having to constantly change the tool.
No.
Yeah. So it's worth talking about what we mean when we say a tool. What
Yeah.
we really mean is a mold,
Yeah.
but it's typically called a tool. And these are these giant blocks of tool steel that are
Yeah, they're
quite
heavy.
impressive. Yeah, and there's actually a crane here
Yeah.
for loading them into the machines.
That's right.
Like developing a tool, what they call opening a tool, is a pretty expensive process and very time consuming.
It is.
We'll do a full detailed deep dive at some point on Strange Parts about it. Let's look at this running. Basically, like very simply, injection molding, you heat up the plastic,
Yeah.
and then you shove it into the mold as hard and fast as you can
Yeah.
and hope that it gets everywhere.
Yeah. The plastic goes down, creating the part. The mold opens.
Yeah. And then you've got a robot arm
Yeah.
here plucking it
It
out.
grabs the part and just
Yeah.
takes it out.
Awesome. Okay, so here's the part itself, and there's grabbing it out with the pushing rods, pushing it out of the mold
Yeah. And going for another cycle.
Yep.
Repeating the
immediately.
process.
Yep. Awesome. Let's go look where it comes out the other side.
These parts are for Prusa mini spool holder.
Okay.
You just clip them together, and if you have two sets, actually
Got
also
it.
put the spool
Okay,
on.
so they would be like this, and then another one here.
Yeah.
Yeah.
And when you take out the parts, like the middle line for the plastic remains, and you can shred it and use it again.
Got it. Oh, and you're actually
So,
feeding this into a shredder right
Yeah.
here. And it seems like it's actually cutting these off as part of the process here, and then it's dropping it there. Awesome.
And shreds it.
And does this? Oh, this is just a very quiet shredder. It's running the
is,
whole
yeah.
time. Oh wow, that's crazy. Put this in here. Cool. I'm here with Miroslav, and you're the head of SMT here at Prusa?
Yes.
Awesome. Well, this is a very impressive line. Why build your own SMT line? There are plenty of services out there.
The main reason is to be flexible when we are building prototypes. So we are really able in 1 or 2 weeks start new project. Normally it can be 6 to 8 weeks externally.
That's a long time.
Yeah.
Yeah. Awesome. So let's just go quickly through the line here. It looks like you're starting with solder paste.
Yes. So this is screen printing machine when we are printing solder paste through the stencils. Stencil is stainless steel shablon with laser cut openings.
Yep.
And we are applying by squeegee solder paste on the PCBs.
Yep. And then SPI, solder
Yes.
paste inspection. It's doing automated inspection and gives you actually a color layout of where the solder paste is. And do you measure thickness as well?
Yeah, yeah.
Yeah, awesome. And then I notice you have 4 pick and place machines placing components. Why 4?
We were starting with 3 machines, but because one of our bigger project, it is the one we are currently running,
Yeah.
has a lot of components, more than 500. So we buy a 4th machine to have it more powerful.
Per
We
hour.
can place around 60,000 components per hour.
Components
it's always
here.
starting with, it's called chip shooters.
Yep.
So we are placing very fast small resistors and capacitors.
Yep.
And other 2 machines are placing bigger components as
Got it.
connectors.
Yep. Yeah. So you've got your
On-
bigger suction heads on this machine.
On the last machine, they are the
Yep.
biggest components we
Yeah.
have.
Yeah. And then your reflow oven. Yep. Awesome. And then let's jump down here. AOI.
This is AOIS.
So automatic optical inspection for making sure that things got soldered correctly. Yep.
Quick touch-up of
Yep.
some failures, which can be easily reworked or repaired.
And then, oh, you've got an X-ray here.
Yes.
Ooh, that's fancy. What are you looking for in an X-ray image of a board?
We are basically looking on pins which are not visible by camera or by eye. Especially it is pins under the body of the components.
Yeah.
At our case, it is Trinamic, which is the driver for the stepper motors. It has, it's called QFN, that package,
Yep.
and it has legs under the body. So you cannot see it by camera or by eye, but you can inspect on an X-ray to see if there is no shorts or open solder or something like
Where
that.
you would have like a blob of solder bridging between two pins. I've not seen this before.
So these are the storing systems. This one is 7.5 meter height,
Oh my God.
and we are storing SMD components. We have 2 of them, but it is still not enough. We have some outer.
Oh, wow. That's crazy. Okay. And this is, why not shelves?
Because this is much faster. About 15 to 20 seconds, you have whatever floor you need.
Okay. Well, thank you, Miroslav.
Thank you.
I'm very impressed. You've done an amazing job here. Thank you for taking the time to show us around.
Thank you.
Awesome. We'll head on to the next step. So I'm here with Ladya, and you're part of the testing team here at Prusa, right?
Yeah.
And so what do you guys do here?
We test all the new printers and all the new firmwares,
Yep.
all the parts.
You guys have quite the crazy office. Machines
Yeah,
everywhere and parts. What is this?
This is our testing farm.
This is awesome.
Here we are testing the Mark IVs. We are not testing only the firmwares, we are testing the new parts like nozzles. It's all
Yep.
labeled, new electronics and even filaments.
I noticed you have not only your filament here, but other manufacturers.
Yeah, here is testing nozzle.
Yep.
So we are testing if it prints good. So
Yeah.
maybe it's not good because it's clogged somewhere.
Okay. And that's, I think, important for people to know is like the whole point of testing is that sometimes things don't work correctly.
Yeah. That's why we are here in this place.
How many machines do you have in here?
Wow, that will be over 200. Here we have the older machines like Mark IIIs, but we still need to run the tests around because it's still supported. So there are newer versions of firmware. Still everything okay, works fine.
So you're making sure that people who bought a machine aren't left stranded
Yeah,
once the new machine comes out. That's great. Wow, Blanca.
So right now we are standing at the expedition, the shipping.
Okay.
So this is how the printers are coming and getting to the customers. So
Got it.
As you can see, it's divided into 2 floors.
Yeah.
On the first floor, there are packed the master products, we call it. So the kits we saw in the production and the complete printers.
Okay.
We everything move upstairs and packed. And on the ground floor, there we pack the small orders like filaments, old spare parts.
Yeah.
And also sometimes the replacements.
Awesome. Well, let's head upstairs and see that, and then we'll come back down.
Yeah.
Okay, great.
There are 2 main lines, the first line and the second line. The packaging line number 1 is mainly dedicated for MK3s, MK4s, complete printers, and for enclosures.
So this is printers coming straight out of the testing and,
Yeah.
and bring up the... And then when they're done, they go on the conveyor belt here?
Yeah, on the conveyor downstairs, and they are put on the pallets for the expeditors. They are making the kits. So we bring them the main boxes with the plastic parts, with the fasteners and accessories, and then we have the engines and other parts, and it's simply put into one box.
Got it.
What I really like about this station that we are still making smaller and smaller boxes.
Oh, that's awesome.
Yeah.
To try and save on shipping?
Yeah.
Okay. Because you
And
guys...
put more on one pallet. So because we are also right now sending the printers to our US company, so we need to put it into a container.
Are you holding inventory in the US?
Yes.
Awesome.
But in past we were not so much focused on the resellers, but right now we are a bit changing our policies.
Got it.
And funny fact, we are sending the Haribos. But there are also some countries that it's too expensive to do the customer clearance, like Mexico.
Oh, because it's food. Oh, got it. So there are some countries that don't get their Haribo.
Because it will be much more expensive to custom clear the Haribo than the printer.
It looks like here is the conveyor belt that goes down to the first floor. Great. Well, let's head back downstairs and we'll see where it ends up.
Yeah.
Great.
Now we are in the part we call it small orders, because usually when you order a printer, you also add some extra parts like filaments, some spare parts like hot ends and something like this. So what we do is that we split it into several boxes.
Yep.
And right now we will see how the small boxes are packed. It's divided into 2 operations. First is picking and then it's packing. So right now there are the operators, they have boxes and they are with the wireless scanners picking the goods to your order. So you can see there are filaments, also the resins for the SLA printers and other stuff. Once the printer is printed on the first floor, then the small order is sent to the queue for the picking. So he will see it in the queue. He put the scanner. There is
you can actually watch her do it here.
Yeah. So there's the position where she should find the filament. So she scanned the position and then she scanned any of code on the
box.
filament.
And then she knows she's got the right thing.
Yeah.
Awesome. And so then those go in totes?
Yep.
Okay.
And it is going to the packing.
Okay. Awesome. Let's go take a look at that.
In fact, the boxes, the totes, it's the queue for the packer.
Got it. Okay, so this is her queue of things she's going to pack.
Yeah.
And so how does she know what orders what?
It depends on the tote. She take the tote, scan the QR code at the tote, and the order is open automatically. Once the smaller package is packed, it's put on the pallets to the shipping companies.
Awesome. So let's go take a look at that. She'll put them all here, and then this gets wheeled over. So this is where you're palletizing?
Yep. So there could be 4 open pallets for different shipping companies. There is small gig, like the maximum height of the pallet.
So these are industrial measurement devices, is what you're saying. Got it.
Yeah, you will be surprised how long does it take to develop this. we tried to print something and so on.
Of course you did, because this is Prusa.
And then the research brings us to the beginning.
That's amazing. So as long as it fits underneath the tennis ball, then it's allowed. Amazing. And then they get shrink wrapped over here and out to a truck?
Yep. So right now we are about 80 pallets per day.
80 pallets per day.
It's because of the XL. There fits only 4.
Yeah. I'm here with David, and you have a very unique role here in Prusa.
I'm mostly the maker of some custom printers or models to events, shows, or when we want to introduce the new materials or products and need some custom models for it. So I made those models.
So you're kind of like almost like an artist in residence or a maker in residence.
Something like that. You go to our booth and the events, all things there, almost like the tables. The frame, everything, we do the painted models, almost everything you see on the Instagram, the short videos of making of and stuff like this, we made it. You can also see the life-size T-Rex in the Prague Zoo and stuff like this. The most models, what you do see there is already painted by someone. So we get the 3D files printed there and just post-process it, smooth it, paint it, and put it on the event or there on the corridors. But there is a lot of models, like the custom printers and stuff like this. We must do the models here. So we model it, sculpt it, and then the whole process.
What modeling software are you typically using?
Mostly ZBrush, Blender, Fusion.
You've got many models that are way too big to fit on a build plate. How are you cutting things into chunks?
90% of the time, we use just the slicer. Mostly the smoothest part of the model. Somewhere on the model, just the little smooth place, there's the place for the cut.
And that's so that you can
fill it. You can easily fill it and
sand it.
And sand it,
Okay. This doesn't have any layer lines. You have clearly some filler on top. What are you using there?
We use a Bondo for plasterboard.
Okay.
Auto fillers, then classic sandpaper.
Yeah.
And then the filler in a spray.
Awesome. And I noticed you have the spray painting station here, the airbrush station, and a spray booth behind. What's the tool you use the most in your...
The vacuum cleaner is, I think, the most important thing in every workshop.
How many printers do you have in total for your operation?
20 MK4s, 4 till 6 XLs, some single tools, some 5 tools, and there is 5 SL1s.
For people who want to get into doing this type of model making, who have a 3D printer, what advice would you give them?
Just be patient. The sanding is a process for a long time. When you want to nice, shiny, smooth surface, you need to be patient. That's all. It's not that hard. I think everyone can do it.
How long does it take you to make something like this?
2 days of printing and 2 days of post-processing. I think
And how long did it take you to slice everything and get it ready to print?
The model is ready. It's from, I think it's from Fotis or something like this. So you cut it, it takes 5 minutes and then you can print it.
That's amazing. Thank you so much for showing us around. This is so impressive.
problem.
You and I could talk all afternoon.
Yeah.
But we have a bunch of other things to go see. We're going to head off to the next building. Thank you so much. All right. Bye. Hi, Tommy. This is amazing. What is
Hi,
this?
Scotty. So we are standing in front of the AFS, which stands for the Automated Farm System. It's a modular system which you can configure, where one of the module is this 9 printer module, where we can put 9 printers in it. Then we can also configure more modules like shelving module, which is behind you.
Right, this here. Yeah.
Exactly. And also in the future, we can add more modules. So these modules are stackable on sides to each other, and we can configure it as the customer wants. We can expand it up to 27 printers, but there are some limitations on the place and area where we can work with. So.
And the idea here is that you can have a print farm that needs less human attendance.
Exactly, because we came out a request from our own farm, where one of the biggest issue is planning, where the data from the ERP systems are crunched through some Excel tables and then put to the production. But basically, we don't need to crunch any data. We can just feed the live data into the system. So it will print on demand. So we can just lower our stocks up, so we can save some space also, and we can eliminate some human factor inside the whole process. So
you don't have to have many farmers and as much work from the farmers. To
exactly, or we can have more farmers like taking care of the printers, like maintaining the printers so they are properly maintained, but not taking care of this like crucial stuff like what need to be printed at what time.
These are not Mark IVs. And they're not XLs.
Exactly.
This is a Core XY printer that I haven't seen this from you guys yet.
Exactly. This is a brand new printer developed specially for the AFS.
Yeah.
But in a really funny way, we can say like it's a XL Mini. The kinematics is the same like XL. Even some parts are same from the XL because we want to save the production costs. But it's much more smaller.
Yeah.
The build volume for this is 260 millimeters by 260 millimeters by 160. So the Z-axis is a little bit lower. Here are the pins for the print sheet, where we need to lift it up out from the magnets. So then the manipulator unit easily retrieve the print sheet.
How do these pins actuate?
Just by lowering the Z-axis way down.
Oh, I see them over here.
Exactly.
Got it. Oh,
So,
that's super smart.
yes.
That's very, very simple.
No electronics, just mechanical solution, and we
that
can
just peels the bed off the magnets,
Exactly.
and then the arm can come in and pull it out.
One feature of the AFS is we want to have something like swappable printers. This is done basically on the fly. So if something happens, the operator can just take out the printer and put the new printer back into its position. The system will automatically detect that this change happened, so he can act accordingly. There are still some stuff which we need to tweak. I hope by the beginning of the 2024, we can deploy these first units into our farm.
Awesome. Well, this is incredible, Tommy. Thank you so much for taking the time. I'm here with Daniel, and you're the head of repair here at Prusa?
Yes, I am.
I feel like a lot of 3D printer companies don't have repair departments.
I believe every 3D printer company should have repair department. One of the main sources for the feedback from the customers. We, as a department and the support, we are at the front end of the company. So we are communicating with the customers. That means not covering the new releases, but also older products that may have some bugs due to newly introduced firmwares. Next door, we receive the printers. We check them against the system, what should arrive, what actually arrived, what's the condition of the printer, who's the customer, what we're dealing with. Basically, we're trying to figure out, based on the description from the customer, what's wrong with the printer. Not only the description might not cover all the issues with printer, but also the customer might use different vocabulary for the issues we're dealing with. So we're trying to meet the customer at his language level. Every technician, they do the full diagnostics. We inform the customer what's the current condition, if they need to pay for the repair or not. After technicians do their repairs, we actually test the printers. We have a set of test prints that we do for each product we have, test different aspects of 3D printing.
Awesome. Well, thank you so much.
You're welcome.
This is so important in keeping printers out of landfills and prolonging their life. So
We're trying our best, actually.
Joseph, thank you so much for having me at your factory. This is amazing.
I'm so glad that you got to see it all.
And if you want to learn more about Prusa and their printers, go to the link down in the description. Also, stick around to the end. Prusa has made a very interesting offer to any Strange Parts fans that are in Prague. Whether it's sharing open source code or sharing models or just giving advice, the spirit of giving to others is a core part of the 3D printing community. And giving selflessly makes a difference in many parts of the world, especially during the holidays. But it's hard to know where resources are the most effective. And this is where GiveWell, this video sponsor, comes in. GiveWell has now spent over 15 years researching charitable organizations and only directs funding to a few of the highest impact opportunities they've found. Over 100,000 donors have used GiveWell to donate more than $1 billion. Evidence suggests that these donations will save over 150,000 lives and improve the lives of millions more. You can make tax-deductible donations to the recommended funds or charities, and GiveWell doesn't take a cut. This is not a paid service. All the research GiveWell has done is available for free for you to check. For example, they don't just tell you that malaria kills over 600,000 people annually, mostly children under 5 in sub-Saharan Africa. They link to research and studies they've done about where money is most effectively spent to combat that problem, and explain how your funds help distribute $5 nets that are extremely effective in saving lives. And here's the best part. If you've never donated to GiveWell's recommended charities before, you can have your donation matched up to $100 before the end of the year, or as long as the matching funds last. To claim your match, go to givewell.org and pick YouTube and enter Strange Parts at checkout. Make sure that they know you heard about GiveWell from Strange Parts to get your donation matched. This holiday season, you can help make the world a bit better. It turns out you guys give factory tours to the public.
Yes, we do. And it is quite easy. You just need to either ping us on the live chat or send us an email and schedule it.
I'll put the email address and information down in the description as well. With that, thank you again.
Thank you too.
And we'll see you again soon.